Hi everyone, welcome to our session, Geospatial Analytics and AI at Scale with Big Data Toolkit. My name is Kyunam Kim. I will cover Big Data Toolkit in detail. Later on, Mansoor Rad will present AI and ML use cases. What is Big Data Toolkit? It's a soft solution from Esri Professional Services that you can use to analyze, aggregate, and enrich big data within your existing big data analytics platform. Because it's a solution, you will not see Big Data Toolkit listed as a product in our website. For more information, please contact myself, or you can reach out to Big Data Toolkit team at the email areas on the screen. We've helped many large enterprise customers to solve their big data challenges. Big Data Toolkit was born based on the years of in the trenches big data experiences. It executes big data spatial algorithms, and it runs directly on your cluster. Therefore, it can read data directly from your own storage, leveraging data locality, and it can also write back to your own storage as well. So, who are targeted audiences? Big Data Toolkit is for users with their own data lake, users with their own big data cluster, either on-premise or in the cloud with Apache Spark 2.0 or higher. It's also for users who needs to be able to read their own data format. It's for users who need to write back to the data lake in their own format. Users who need to process massive location data without any GIS knowledge. And interestingly, it is also for users who's using the open source tools out there, but not being satisfied. For example, we've seen customers using open source tools that require you to build spatial index first, which takes pretty long time. Even with the spatial index built, the performance was not impressive. And some other customers, instead of being able to process data for the nationwide in one shot, some customers divide their data set into smaller regions, then process each region one at a time. So the whole process experience is very clunky. If you are in the oil and gas industry, you can use Big Data Toolkit to analyze telemetry data set coming from wells and tankers. Wireless communication customers use Big Data Toolkit to analyze call data records. And insurance companies find Big Data Toolkit very useful because of its map matching capability. They can analyze your driving behavior to decide your insurance premium. And government agencies can also use BDT to track bad guys by identifying patterns of who's talking to whom and how often they talk to each other. Big Data Toolkit is an Apache Spark application that you submit to your cluster. Therefore, there is nothing to install. Each time you need to process massive location data set, literally you Spark submit the program. In this case, it's Big Data Toolkit jar file with the instruction to tell BDT what the toolkit should do. I will cover this in more detail in the upcoming demo. So what's in the Big Data Toolkit? Big Data uses Esri core geometry library in order to perform various spatial operations. With the library, it also comes with projection engine so that you can project from one coordinate system to another coordinate system on the fly. It comes with API and SDK that are written in Scala. When you sign up for BDT subscription, you get access to our private source code repositories. If Big Data Toolkit does not have what you are looking for, you can extend our API to write your own custom processors, sources, and sinks to implement your own business logic. We build BDT using Apache Maven. BDT also comes with ArcGIS Pro toolboxes that are written in Python 3 using ArcPy to allow you to export GIS data to the data lake. You can also use them to query the data lake through the interactive query engine such as Apache Hive from your ArcGIS Pro. To be clear, you do not get access to the source code for Esri core geometry library. In BDT, there are three types of components: sources, processors, and sinks. We use source components to read the data sets to process. In addition to reading CSV files, TSV, Parquet files, Hive tables, database tables, I want to highlight that we can also read directly from the file geodatabases. In this case, all you have to do is to copy your file geodatabase to your storage, such as Hadoop file system. We can also read a bunch of shapefiles from your own storage as well. In the middle, you are looking at currently available processors, except the gray ones. Gray ones are planned for the future. To highlight a couple of popular ones, processor point Polygon is very popular. This is the processor that you use to enrich massive point data sets with attributes from Polygon data sets. Processor distance and processor intersections are another ones that are very popular. As for the sinks, I want to highlight you can now write to the enterprise geodatabase such as SQL Server, Postgres, or Oracle with native geometry format. You can also write to ArcGIS Spatial Temporal Big Data Store. When you persist to ArcGIS Spatial Temporal Big Data Store, you get feature service, map service published automatically as well. So to invoke BDT, you do Spark submit on your cluster. To use BDT, you don't need to know Scala at all. All you have to do is to write a configuration file to tell BDT what to do. Now it's a demo time. Let me switch over to demo environment. So for today's demo, I have a little tiny cluster up and running in Azure HD Insight. Let me show you how to invoke BDT in your own cluster. What I'm going to do is this. I am going to Spark submit the program, in this case, BigDataToolkit jar file, with configuration file that I'm about to supply and the license file for BigDataToolkit. This time, I am asking the cluster to give us this much resources, compute resources. This time, I am asking, give me 3 executors, and each executor has 12 virtual cores and 47 gigabytes of memory. So let's kick this off. So job has been submitted, and let me give you a quick tour of the cluster. So I have HD Insight cluster in Azure. I go to Yarn, Manager, and I see at the top row is the Big Data Toolkit job that I just submitted. If I move over to Spark user interface, I see all 3 executors doing their jobs. Now, let me go in detail what's happening as of now. So that configuration file that I just submitted has 3 main sections: sources, processors, and things. In sources, this is where you define about your data sets. And processors, you define what to do with your data sets. And things, you define where to put the output to. In these sources, today I am using 2 data sets: taxi data sets and zip code boundary data sets. For the text data sets, I have 12 million records in a CSV file sitting in this path in my storage file system. I am using source text component to read the CSV file. That CSV file has 19 columns. Among that 19 columns, I am retaining these 6 attributes: total amount, tip amount, drop-off locations, and pickup date time and drop-off date time. I'm telling BDT, by the way, 5th and 6th columns are longitude and latitude of the pickup location. So I'm telling BDT, pick up those 2 columns, create point geometry on the fly. That's about it for the text data set. For the zip code boundary data set, I am telling this is the path of the text file. By the way, job has finished already before I even finished talking about what's going on. Anyways, yes, this is where the data set sits. I am using source text. By the way, this particular data set has more than 2,000 demographic variables. And I'm telling 2121th column is the column containing well-known text values for polygons. So I'm telling BDT, pick up this column, create polygon geometry on the fly. And I am retaining only 2 attributes from them: zip code ID and median household income values. Processors. What I'm doing first is this. I'm using processor add calculate field to add brand new column on the fly. And this time I'm calculating the values for the brand new column using 2 existing values, tip amount and total amount. I do the division between them. And I name the new column as tip normalization. Next, please notice the output from the previous processor becomes the input to the next processor. This time I have point data sets, polygon data sets. I am doing processor point polygon. After that, I am doing, I'm constructing conceptual 2 different sized hexagons, because in the end, I want to see on the map hexagon aggregated maps. So in this case, I am creating 200 meter sized hexagons and 500 meter sized hexagons. Once I have those hexagons, I am doing simple summary statistics. In this case, for 200 meter hexagons, I am calculating average of tip normalized values. I do the same thing for 500 meter hexagons. And in the end, the last 2 processors, I am turning conceptual hexagon representation into actual polygon representation. In the end, what I want to do this time is I want to persist those two different sized hexagons into two different database tables. So I am grabbing 200 meter sized hexagons. I'm telling BDT, go talk to SQL Server, create this table, hex200, with my login information. By the way, when you persist those information, I also want you to create spatial index along with it. And I do the same for the 500 meter hexagons as well. Again, all this took 2 minutes and 27 seconds. Now, what does that look like on the map? I go to Pro, look at the database connection. I see two tables popped up, literally grab and drop, hexagon shows up. I do symbolize, graduated colors based on tip average column that was created on the fly. Then you get to see nice heat map. I do the same for 200 meters. Symbolize the same way. This time you get more fine-grained hexagon aggregations. So the higher the color, the higher the intensity indicates if you were the taxi driver and if you were to pick up the passenger in that area, chances are you're gonna end up getting better tips. So that's the end of first demo, and I have another demo, the second one. This time, what I want to do is this. I want to use same taxi data set, zip code data set. I want to do processor point polygon, enrich point data set with attributes from the zip code attributes. And then for a particular zip code, I want to calculate these two simple values, sum of total amount and average of tip amount. And this time, I want to see the output on the screen. So I ran this before the session. It took about 1 minute and 40 seconds, and the result looks like this. The summation of total amount is this, and the average of tip amount is this. The purpose of this second demo is to show you the sneak preview of next generation of Big Data Toolkit. In the next generation of Big Data Toolkit, you can run Big Data Toolkit jobs in your notebook environment. Today, I am using Databricks notebook environment, and I have a cluster up and running in the Databricks notebook environment. And this time, I'm using much smaller cluster. This time, I have 3 workers. Each one of them has 28 gigabytes of memory. Let me switch over to notebook. So I literally translated what I just described in this configuration file into pure Spark SQL. Again, I am reading 12 million records from CSV file. I create shape information out of it using longitude and latitude values of pickup location. And I do spatial partitioning in BDT. And I register the data set in the memory with the name taxi. I do the same, pretty much the same for the zip code boundary. I read from file system, the text file, or the demographic variables and well-known text representation of the polygons. And I create polygon geometries out of it. And I do spatial partitioning at the same time. And I register that data set with the zip name. What I do next is pretty much the same thing. I do join these two data sets, but this time, instead of explicit point polygon processor, I do something similar, ST contains, meaning per a polygon, given a polygon and a point, does this point belongs to within this polygon for this particular zip code, and I get the same results back. This time it took only 8 seconds instead of a minute and 37 seconds. The difference this time is this. If I go back to Yarn Manager, look at that job history. When I look at DAG, directed acyclic graph, this is the step that Apache Spark took with current Big Data Toolkit. So it reads a data set and another data set, do some repartitioning, and then co-grouping, which means we are doing point polygon in here, and then summary statistics of sum of total amount and average of tip amount. This is what current Big Data Toolkit does. In the next generation, if I look at same DAG graph, it's a lot simpler. The reason is this. These functions that you see is something called catalyst expression. It's not user-defined functions. It's catalyst expression. If you Google search project Tungsten Apache Spark, in this project, we take their two main advantages. One is we take advantage of their raw memory management, and we also take advantage of code generation, which means each expression generates Java code on the fly for Spark to compile on the fly and throw the one big function collected from all these tiny other expression functions. So they make really big function and they throw at your data set. Let me stop here. This is my end of second demo, and I would like to hand over to next presenter, Mansoor Rad, on AI ML use cases. Thank you, and I hope this was very useful. And if you have more questions, please contact us at bdt_support@esri.com. Thank you. Hello, everyone. Welcome to our session, Geospatial Analytics and AI at Scale with Big Data Toolkit. My name is Kyunam Kim. I am the tech lead for Big Data Toolkit. There are two parts in this session. I will introduce you to Big Data Toolkit in this first part. In the second part, Mansoor Rad will present AI ML use cases. What is Big Data Toolkit? Big Data Toolkit, or BDT in short, is a soft solution from ESRI professional services that you can use to analyze, aggregate, and enrich big data within your existing big data analytics platform. Because it's a solution, you will not see Big Data Toolkit listed as a product in our website. For more information, please contact myself, or you can reach out to Big Data Toolkit team at the email areas on the screen. So, who needs Big Data Toolkit and why? Well, let me describe the typical customer story of Big Data Toolkit. Let's say you have a big data cluster, either on-premise or in the cloud, and you get flooded by massive location data coming in every day from smartphones, cars, financial transactions, and you use Hive and Spark to plow through your data sets to analyze what you need to find out. And also, you are using open source tools out there to perform spatial operations, but you are not happy because 1. The performance is slow. 2. The spatial operation capabilities are limited. 3. Many preparation steps are required before doing any analytics. For example, with some tools out there, you need to build out spatial index first, which takes pretty long time. And you need to have your data set in certain format and location. And 4th, you cannot even process at scale. So you divide your data set into multiple smaller geographical regions and process one region at a time. So the whole experience is very clunky. This is where Big Data Toolkit comes in to rescue you, because 1, BDT runs on your cluster directly. 2, BDT reads your data set from your cluster, leveraging data locality, or your storage can be somewhere else, such as S3, Azure Blob Storage, etc. 3, your data can be in any format. 4th, BDT writes output back to your storage. And lastly, BDT does not require to build spatial index, and you don't have to break up your data set into smaller chunks. And if you happen to have ArcGIS Enterprise in-house, even better, because BDT can pull GIS dataset out of your enterprise geodatabase to the cluster on the fly. Once processing is done on the cluster, BDT can write back to the enterprise geodatabase, such as SQL Server, Postgres, in native geometry format, so that you can take it to the next level by using hundreds of advanced spatial analytic tools in ArcGIS. Additionally, BDT can write to ArcGIS Spatio-Temporal Big Data Store. And there is a bonus in doing this. That is, you get both map service and feature service published automatically. In Big Data Toolkit, there are 3 types of components: sources, processors, and sinks. We use source components to read datasets to process. In addition to reading CSV, Parquet files, Hive tables, database tables, I want to highlight BDT can read file geodatabase and shape files as well. All you have to do is to copy your file geodatabase and shape files to your storage, such as Hadoop file system. To highlight a couple of popular processors, processor point polygon. You use this processor to enrich massive point datasets with attributes from polygon dataset. Another one, processor distance. Given 2 datasets, for each feature in the first dataset, you can find the closest feature in the second dataset. Processor smart snapping, also known as map matching, is also a popular one. I will explain a little more about this in a minute. So to elaborate a little more a little more on smart snapping. If your dataset has GPS breadcrumbs at every second with heading values, speed, all kinds of other measurements, but latitude and longitude are only updated at every 30 seconds interval. Despite GPS measurement is noisy, we can infer how you traveled between 30 seconds intervals by calculating the best probability on the street network. As you can imagine, this is very popular in automotive manufacturing industry as well as insurance industry to find optimal insurance premiums based on your driving behaviors. So what's in the Big Data Toolkit? Big Data Toolkit uses Esri core geometry library in order to perform various spatial operations. That library comes with the projection engine so that you can project from one coordinate system to another on the fly. It comes with API and SDK that are written in Scala. When you sign up for PDT subscription, you also get access to our private source code repositories. If, for some reason, Big Data Toolkit does not have what you are looking for, you can extend our API to write custom processors, sources, things to implement your own business logic. We built BDT using Apache Maven, and BDT also comes with ArcGIS Pro toolboxes that are written in Python 3 using ArcPy to allow you to export GIS data to the data lake. You can also use them to query the data lake through interactive query engine such as Apache Hive from ArcGIS Pro. Just to be clear, you do not get access to the source code for Esri core geometry library. So it's demo time. In this first demo, I have 35 million New York taxi records and 360 zip code boundaries with more than 2,000 demographic variables, such as total population and median household income. We will calculate and add a new value onto the taxi dataset, enrich taxi records with demographic attributes from zip code boundaries, hence point polygon, create 200 meter and 500 meter hexagons, generate simple statistics based on those 200 meter and 500 meter hexagons, and persist this information to the enterprise geodatabase. In this case, we're going to use SQL Server. Then we will visualize what we have done in ArcGIS Pro. Okay, so let me get out of this presentation mode. Then here's my terminal window. Okay, for today's demo, I am using a small cluster in Microsoft Azure HD Insight. Let me give you a quick tour of the cluster that I have. Azure HD Insight, cluster size. I have 3 worker nodes, and each one has 56 gigabytes of memory in a core. Now, let me go back to my terminal window and let me show you what I'm about to do. What I'm about to do is, by the way, if I didn't mention in previous slides, Big Data Toolkit is a Apache Spark application, and most of Big Data cluster is equipped with Apache Spark already, so there is nothing to install. All you have to do is submit our Big Data Toolkit job to the cluster. So here, I'm about to do Spark submit with the program, which is our Big Data Toolkit jar file, with instructions that I'm about to supply, which is nothing but a text file and license file for the Big Data Toolkit. So let me kick this off. Come on, you can do this. While this is up and running, let's make sure our cluster manager, Yarn, is working as expected. So Yarn cluster manager, I see my Big Data Toolkit application is registered and up and running. Application master, Spark job kicked off, executors, they're busy, good, and all the stages to be executed as well. So let me explain what's going on at this moment. So in Big Data Toolkit, all you have to do is create a simple configuration file to tell what Big Data Toolkit should do. So in the configuration file, you define three conceptual stuff. One, sources. This is where you define your data sets are. And processors. This is where you define what to do with those data sets. And sinks. This is where you define the location where you're going to put the output to. So in sources, oh, by the way, I meant to update this. We have 35 million records of taxi points data set, and we have a zip code boundary data set. For taxi data set, this is the location of CSV files that I have in my storage account in Azure HD Insight. And this taxi CSV has 19 columns, and I am telling it to retain only these 6 attributes. By the way, 5th and 6th are the longitude, latitude values. So I'm telling it to use those to create point geometry on the fly. So that's about it for taxi data set. And zip code boundary data set, this is the location of the text file. And the text file is tab delimited. And this data set has more than 2,000 demographic variables. But in this demo, I am only interested in carrying zip code value and median household income value. By the way, the very last column in this text file is 2121, 2121th column is the column that has well-known text values for the polygons. So I'm telling Big Data Toolkit, please pick that up, create polygon geometry on the fly. So I have 2 data sets defined in sources section. In the processor section, first thing that I do is to use processor add calculate field to add a brand new column by using the existing columns. In this case, I'm using tip amount column, total amount column. I do the division between the two, and I create a brand new column named tip_norm. And the output of this processor becomes the input to the next processor, in this case, processor point polygon. So we are giving point data sets as a first data set and polygon data set as a second data set. We are enriching or spatial join between the two. We are enriching point data sets with attributes coming from the zip code boundaries. And third, I wanted to create 200 meter hexagons, 500 meter hexagons. So long story short, I am enriching the point data sets with additional information about hexagons, 200 meter, 500 meter. And I'm turning the conceptual hexagon information. Oh, let me go back a little bit. Once I have conceptually created hexagons, I do a simple statistics here. So per hexagon size, 200 meter, I am calculating average tip_norm column. And I do the same for 500 meter hexagons as well. Then finally, I am turning that hexagon, conceptual hexagon information to actual polygon geometries. So I am creating two brand new data sets on the fly, one containing 200 meter hexagons and the other one containing 500 meter hexagons. Lastly, I want to persist those two information into enterprise geo database. So I am creating a table, in this case in SQL Server, with the name hex200, and this is my database information. And I'm telling it, using native geometry format, create polygon feature class. By the way, when you create this table for the first time, I want you to create spatial index as well on the fly. So this is the grammar that you tell in SQL Server to impose spatial index on this table. And I do the same for the 500 meter ones. Now, what's going on with the job? It finished in 3 minutes and 29 seconds, all those steps. So let me switch over to ArcGIS Pro. Resolution is kind of screwed up, so let me kill this. And bring this up. Continue. Okay, much better. So I go to database. I already established the database connection. Please show me to, oh, here we go. We have 200 meter database table, 500 meter database table. Simply drag and drop. Ta-da, hexagons. Then I want to symbolize those hexagons based on brand new column I created, t_average. Ta-da. So the higher the intensity of the color represents, if you were to be a taxi driver in New York City, if you go to those high intense color area, the chances are you will get better tips. I do the same thing for 200 meter and click on symbology, graduated color. Now you get much more fine-grained hexagons. Okay, so that ends my first demo. I have a second demo. At this point, we are working on next version of Big Data Toolkit. So I wanted to give you a sneak peek at it. And this time we are targeting new audience, data scientists. So you can run Big Data Toolkit next version in the notebook environment. So let me get out of the presentation mode. Let me kick off another BDT or Big Data Toolkit job. While this is running, let me explain what this configuration file does. This time, almost the same. I'm using same taxi data set, and I'm using same zip code boundary data set. I do point polygon, but this time I'm using processor SQL to do simple statistics for a particular zip code. So this time for this particular zip code, just give me these two simple summary statistics. And in the end, show me the results on the screen console instead of persisting to the disk. So this should run pretty fast. Let us give a few more seconds on this one. Let me double check, nothing is choking. Getting there, almost. Horses are busy. In the meantime, let me bring it up. Databricks notebook that I'm using for the second demo. So go to Big Data Toolkit 2, Resource Group, Databricks Service, Launch Workspace. And for this time, the cluster that I'm using is half the size of what I used in the first demo. This one has only 3 worker nodes, and each one has only 28 gigabytes memory and 8 cores. It's almost half the size of what I used in the first demo. Let me go back to that. Oh, now it's done. The job is done in 1 minute and 54 seconds. And for the particular zip code, sum of total amount, average of tip amount is R. It is 2 values, 1.47 and 1.688. Now, what I'm about to do to give you a sneak peek at Big Data Toolkit version 2 is this. I translated that same logic in pure Spark SQL this time. Again, the next version BDT, you can use BDT in the notebook environment, and you can express your business logic or your old or current configuration file logic. You can translate all those into Spark SQL way. So in this case, I read taxi data set that has 35 million records and read that first, create a shape field, point geometry out of it on the fly based on these two latitude, longitude value. And I do a little bit of magic to do spatial indexing on the fly. And I register that dataset as a taxi dataset. I do the same for the zip code boundaries. Again, read this simple text file representing zip code boundary polygons with more than 2,000 variables. Using the well-known text field, create polygon geometries on the fly, and do a little bit of a spatial magic, spatial indexing magic, and register that dataset with this zip name. Then I do the same aggregation that I did in the current version of BDT. So this time, for this particular code, give me back these two simple values by doing spatial joining in this manner. So let me run this. It was in the idle, so it's taking some time to get warmed up. So let's give another few seconds. It's finally running. So it took 23 seconds. I hope I am making you go wow at this time, but let me give you what the difference is. Let me explain what the difference between the current and the next version coming up. In the current version, let me go back. In the current version, if we take a look at what Spark has done, is these many steps. We read one data set, we read a second data set, do some repartitioning, and do joining, and then do summary statistics SQL statements. In the new way of doing things, steps are much simpler, and it took only 23 seconds. And since it is warmed up, if I re-execute, I expect to be a lot faster this time. Or maybe not, but let's give another try. Come on up. Ta-da! This time, 21 seconds. And I get the same value, 1.47 and 1.688. So, back to the slides. What just happened? In next version of BDT, we are transitioning from RDD to data frame and SQL. RDD stands for Resilient Distributed Data Set, and we are moving into data frame based. By doing so, we are taking advantages of what Project Tungsten offers. The memory management and binary processing, Tungsten tackles Java objects memory overhead and overhead of garbage collection by introducing an explicit memory management to operate directly against binary data rather than Java objects. Cache awareness. In short, CPU time spent waiting for data to be fetched from main memory is not cheap, so they improved it through the effective use of L1, L2, L3 CPU caches, and it helps with sort-based shuffle, high cardinality aggregations, and sort-merge join operator. Third, code generation. All those custom Big Data Toolkit functions that you saw in the notebook, each function generates Java code on the fly. Let me repeat, it's a Java source code it generates on the fly. This code generation reduces the boxing of primitive data types and avoids virtual function calls, which slows down execution. This is the end of my part in this session. I hope I made all of you excited about Big Data Toolkit. And again, if you want to find more information, please contact myself or the Big Data Toolkit team at BDT_support@esri.com. Thank you for watching.